So with that, we move on to the Soma. So thank you so much, sir. Really, that was wonderful. Great to have your thoughts. We move on to the third speaker for this session. It's this one is not even so much from here, but from the heart. It gives me incredible pleasure to introduce, ladies and gentlemen, to you, Ramesh K. Maini, CEO and President of Zentech. Ramesh has served as the President and CEO of Zentech since Zentech's inception, which he founded more than 40 years ago as one of the founding partners. As the CEO and President, he's managed a variety of oil and gas industry projects, as well as NASA, US Navy, and US Air Force projects. He's personally been involved with major design modifications and enhancements of over 100 marine drilling vessel types and other vessels for wind farm applications, vessels to clean the oceans, and I could go on, but I picked a couple that were in and around this energy transition topic of today and the sustainability of energy supply. Ramesh has actually been carefully selected among the top experts in the industry by International World Oil Panel as most innovative thinker in the oil and gas business. And he was also the winner of the AISE, the American Society of Indian Engineers and Architects Eminent Engineer Award. Ramesh received his MS degree in structural engineering from the University of British Columbia, Vancouver in Canada, and a degree in civil engineering from IIT-Bombay in India. He is also a fellow of the Society of Naval Architects and Marine Engineers. He's a professional engineer in the state of Texas, the American Institute of Steel Construction, and the National Society of Professional Engineers. My usual little personal touch of the end of each introduction, I had the great honor and privilege of meeting Ramesh at the Pan-IIT conference in 2013. And the best words I can use to describe Ramesh on a personal note, he's truly one of the most genuine people that I've ever met in my life. And I have the great privilege of being able to call him my elder brother. Ladies and gentlemen, I give you Ramesh Maini.
Thank you, Sandy. This is way too much. First of all, following Ashok and then following Soma and listening to you, giving me the accolades that I probably don't deserve half of it. But, and by the way, with all these two wonderful talks by these two brilliant gentlemen, it's hard to follow with a little guy like me. I am not a big company like these two gentlemen are with the companies they are, but all the same, I want to say hello to all the brilliant minds in this talk. First of all, Sandy, thank you for even bringing me in here. But and so is Witty, thank you. On top of that, you know, I want to thank and congratulate all the volunteers, the IITians who are supporting this project that all of you all have brought to life. And it shows the great credit to the IITians as a whole, which I'm very proud to be one of them. At the age of 16, I joined IIT Bombay in 1962 on a 5-year course. And those days from high school you went to, and it was a 5-year course. But after 53 years, I'm still working and enjoying every bit of it. The reason being the brilliant engineers I work with and a lot of my customers and clients, the likes of Ashok, who give us a lot of challenges to bring a lot of good engineering talent, if you will. You know, the topic of reinventing here, I'm sorry I didn't bring any slides.
According to the meme.com.
So forgive me for stop. I got Alexa here trying to give me some instructions. So please forgive me for that. But you know, every one of us around here looking at all the things that have happened around us in the industry in the past, currently, in the future, they're all have been the reinvention of engineering. You know, every day we do something in engineering And I don't know if any profession that does what engineering does in any profession, whether it is cooking food at home, or all of the equipment that comes into it, or whether it is sports, all of the technology that has gone into the sports, whether it is going to the moon and or Mars, that's been all engineering. So those are all reinvention of engineering, if you will. These brilliant minds that I call myself one of them. All the IITians are such brilliant minds. They're bringing world over some great results. Every day, you all bring the most out of each industry. I can't talk about each profession or each industry. I can only talk about the industry that Ashok has talked about and so much talked about. That's the oil and gas industry. Since 1972, I've been in this industry. And I've had the pleasure of working with lots of great people. As a company, we design, we build, and we perform construction management on a number of mostly offshore, but some onshore drilling rigs. So even in the oil and gas industry, as a company, we're in a small part of drilling rigs. What I want to tell you is, these brilliant people are on the panel here. They already know all these things, but you know how in the 50s we were on land, in the 60s we started going in shallow waters, and then in the 17s, 80s we went into mid-water depths like 500 meters, and then in 90s and went into 1,500-meter water depths, and then now in the 20s we're going into 10,000, 12,000 foot water depth, which is about 3,500-meter water depth. That's reinventing engineering, if you will. And we've been part of it, a lot of that development. And, the all elements of engineering, whether it is naval architecture, whether it's structural, mechanical, electrical, metallurgical, all the engineering disciplines perform in this field. Of course, the people present here know all about drilling rigs, but people who may not know about the drilling rigs, it's an island that floats, that moves from country to country, from the ocean to oceans, that can drill anywhere in the world, whether it's in the very heavy storms, or whether it is very cold environments, or whether it's very warm environments. We have to have all kind of mechanical means to have weather, capability to withstand weather, whether it's in winter or it's in summer. So we have ACs, we have heat, we have to have the steels that are designed and used for weathering all kind of conditions. Some 200 people live on board these days that serve the industry, working 24/7, 365 days a year. Whether it's Christmas, whether it's Thanksgiving, whether it's Diwali, whether it's Dussehra, people still work on board 2 shifts a day and perform. Looking at the technology from reinventing engineering standpoint, we started drilling in 5,000 PSI, something 350 bars. We went on to, in the 1780s, went on to 10,000 PSI, some 700 bars. And then in the 90s, we started 80s and 90s, we went into 15,000 PSI. Now we're in 20,000 PSI and still growing, maybe even 25,000 PSI in 3,000 and more. But all the other reasons that we're doing things that helped us. Imagine being in 3,000-meter water depth and then drilling still 4, 5, 6, 7 kilometers in the ground to produce oil and water. Those are all some engineering talent that that has been brought on by the brilliant minds. I say all these things is because of the youngsters who are there in the industry, despite all the other news about how bad some people think oil and gas has been. We all know that oil and gas is not going to disappear. The brilliant minds are going to still continue bringing a lot of the great things. So, there are other innovations that have taken place, like the horizontal drilling. Used to be we drilled 10 wells, we find one successful well. Now we probably do more like 1 out of 2 wells. Those are all the innovations of engineering. Shale oils and oil sands and all of these are newer innovations. We are working on some of the marginal fields right now. There were times when marginal fields were left alone, and we're working on developing those, not only just we, but industry as a whole. But, against all odds, when everybody is against the oil industry, we all have to reinvent ourselves to other engineering sites. So the wind producing energy, solar energy, the thermal energy in the ground, wave-induced energy, and or like the likes of Bill Gates, who has come up with brilliantly safer ways of having nuclear power. These are all going to be the newer technologies that are going to solve actually the power-related problems, but oil and gas is still never going to disappear. So, as an industry, the innovations are many, many more. Look at the virtual reality, look at augmented reality, artificial intelligence. We all are working in predictive analytics now to where we can look at the equipment from all aspects to give it a longer life. We are using virtual reality, using 3D cameras to scan structures that we can know within 1 to 2 millimeter accuracy how we can modify equipment on the vessels or drilling rigs or platforms or even the other kind of vessels that are confined environment. So, all of this thing is resulting in more and more innovations that are resulting in better, safer, productive aspects for human resources and human needs. So, as a company and as an industry, our industry has been always looking forward to doing more and more things. Recently, we tried to come up with something newer. For example, all ships, boats, barges, drilling rigs, offshore platforms, we all have ballast tanks, which are using salt water. And you see that after a few years of a new construction, all of them develop corrosion. We have recently gone into where we can, without entering a tank, we can scan a tank and show you the condition of the tank, whether it is in good condition or in corroded condition, as if you're sitting a foot away from it, looking at it like you're there in that room. You could never do that before. Without any light, without any human intervention, we can scan a tank and tell you what the condition is. And then you decide if there is something has to be done. In the past, there have been some rules to modify structures because there's some rules says 15% loss replaces steel. We can now prove to you sometimes even 30%, 35% loss is not necessarily replacement, or sometimes even 5% has to be replaced depending upon where in the structure that's a problem. This is predicting and creating assets to have a longer life. The intent is that we are all, especially in our industry, we're struggling to keep the economy in such a way that the costs are brought down. So we're working towards some of these aspects to bring the costs down. The ballast water treatment, the escape gases from the engine rooms, all of that has been newer laws, as Ashok talked about carbon capture, and as Soma talked about some of these things. We're all working towards that. This is the beauty for all the youngsters, Sandy, as you ask. They are going to be looking at all of these things. And we went into crack propagation studies where if you had a small crack or inclusion, we could actually predict how long it'll be before that crack becomes non-effective to where you have to do something about it. In the past, we look at a crack and we say, oh man, this is this equipment or this structure is going to fall. In the reality, that is not always so. The CFD studies that industry does, where even when we have a ship rolling at under very, very heavy storms, how the liquids are hammering the tank walls and the roof and the bottom of the tanks, you can actually predict what's happening and how you can design things. Those are all some interesting engineering aspects that the likes of the IITians that are going through schools are going to use. But we have some other challenges. For example, there are over 8 billion tons of plastic floating around the world. We talk about green energy and we talk about windmills and other things, but somebody's going to have to work towards removing all these plastics. Some of us are very keen on eating seafoods, and some of this plastic that are floating around is also coming back into our own stomachs when we so-called enjoy seafood. So we have to work towards one. Now, another aspect of windmill industry that very few people have looked at it, some 20 years ago, we started installing windmills. The blades that now those windmills are being dismantled because bigger and bigger windmills are coming up that can generate a lot more power, less pricing than the old ones were. So they are discarding or dismantling some of these old ones. These blades are 75, 80 meters long or 200, 250 feet long. You cannot move them easily. If you cut them, that's a fiberglass material. There are not very many uses for all that. So some other youngsters are going to come up with better engineering capabilities to have to figure out how to, discharge those things. We can't just call West Management and come here, pick up these blades, and they'll do something with it. They can't. And the future blades that are about 108 meters long, 325 feet long, if you will, they're made out of carbon fiber. And as I understand from a lot of people, they don't even have an answer yet. What are they going to do when those blades have to come back and have to be dismantled? These are some of the other innovative things that people have to come about. And the youngsters, I'm sure, will come up with a lot of things. So for me, working as old as I am, the exciting part has been working with brilliant people who all think great things, and I learn and enjoy around them. The likes of Ashok and Soma brings a lot more things into the industry, and I enjoy those things as well. In closing, I have a request. Indians are, in general, all over the world are doing very well. We have Indians have brought a lot of good name to India, and world over, really appreciate what all do. I just like everybody to be proud of all the other Indians. We should be a team that really look at each other and look at our kids, look at other people's kids, and really appreciate each other, because that's something that we don't do very well. Maybe I'm wrong in saying that one, but that's something is a request that we should all do. We should all praise each other thoroughly because we all deserve it. And a good praise brings the best out of everybody. So with that, Sandy, I say Jai Hind. But if there is any question, which I doubt there's anybody going to have any question, but I'm ready to answer if I know something. You're mute.
Thank you, Ramesh. I appreciate that was coming from the heart. I know we had a bit of an issue about slides, and it might have been easier, but thank you for that. And so I'm not going to ask you the standard question that I ask all the other speakers about your message for students, because you did address this in your speech. But maybe a slightly different question, which is, you saw that very plaintive question about, oh my goodness, what's going to happen to oil and gas? Ashok addressed what they are potentially looking to do from their company point of view, and Soma looked at it from ChampionX's point of view. So any thoughts around that as to survival techniques, I guess, if nothing, for want of a better phrase? Yeah.
Well, I don't believe the oil and gas is going to totally disappear. Okay, even 100 years from now, it's going to be there, and there's going to be more and more research and better things going to happen. We're already doing all sorts of things about trying to take care of the pollution, take care of the exhaust, the dumping of ballast water in the sea. We're doing all kind of things as an industry. So yes, it's good to have some other challenges. It brings the best out of everybody. Soma was right. I think Ashok said that there'll be some of the companies will probably merge with others and there'll be some shortage. But, we went through 80s the same way what we're going through right now in the oil and gas industry. We've always come out with the bigger and better things and done well. I have no doubt in my mind, I may not be around to see it, but I think things are going to be always going on. But it's always exciting to see other innovations that happen, and youngsters are all going to be working towards all of that. I don't know if I answer your question, but that's all I can say.
No, that's fair enough. This is each person has a different strategy, if you may.